So before we move on to the last example, I forgot to mention earlier, based on your this equation here for A and B, since B the reaction order is zero, we don't really need to include it into our rate law equation. So you can simply just take this out. Okay, because why? Since the reaction order is zero, concentration doesn't affect the rate. And based on the rate law shows us how concentration affects the rate. So for this reaction, it's going to be rate is equal to K times the concentration of A to the power of 2. Okay, so here's my rate law equation for this particular reaction. And only A, by changing the concentration A, it only affects the rate, not B. Okay, last example. Let's use a real equation this time. So here it is. We have NO and H2. Okay. These are my two reactants. So I'm going to set this up. My rate, okay, is equal to K. So concentration of NO to the power of N, the sulfur reaction order. And my other reactant is going to be H2. So instead of using N, I'll use P this time. Okay, so it looks like we have two reactants. Sometimes we might have three, or maybe just one. Okay, and here's another misconception: you don't need to look at the balance equation to. You can't. Excuse me. You can't use the balance equation to help you figure out the reaction order for this reaction here. Okay, you can only use the initial rates and the experiments that I'm going to provide for you. Okay, unless you're in a laboratory setting and you're collecting data to figure this out. Okay, so let's start with NO first. Okay, so again, I'm going to use green for NO. Okay, so which two experiments? Make sure again you pick the ones that's changing, but you want to leave H2 the same. Okay, so I'm going to probably pick experiment for NO 1 and 3. Okay, so again, I'm changing NO, but I'm leaving H2 constant or the same. Okay, so here are my two rates. Okay, so you notice as you increase the concentration, you're doubling it. The rate is going to be increasing. Okay, so I'm going to show my work using ratios. So which means the left side, the rate. I'm going to do again. This is going to be for NO 0.492 over 0.123. I'm going to set it equal to 0.200 over 0.100 to the power of n. Okay, so which means this is going to be 2 and 0.492 divided by 0.123. That should give you 4. Okay, so it looks like n is going to be 2. So the reaction order for NO, I'm going to come back to this and erase this one out for you guys. Erase this. Okay, so it looks like N. Okay, it's going to be 2. So what does this mean? It means if you were to double the concentration of NO, the rate's going to increase exponentially by 2. So which means going from 0.123 to 0.492, you're multiplying it by 4. Okay. Cool. All right, last thing, H2. I'm going to use a different color pen. Use red this time. Okay. So which two experiments? I'm probably going to pick 1. Let me circle this. And 2. Okay. So you want to change the concentration of H2. And for NO, you want to make sure it stays the same. Okay. So the last thing, I'm going to set up the ratio. Okay. So it's going to be 0.246 over 0.123. Okay, set it equal to 0.200 over 0.100 to the power of p this time. Okay, so this. So this is going to be 2p. Okay, 0.246 divided by 0.123. That's going to be 2. Looks like p is going to be 1. Here we go. So so the reaction order for H2 is going to be, erase this. It's going to be 1. Since it's 1, I'm not going to put the 1 for the exponent. It's not necessary, so I'm going to circle this. So at the end, here's my reaction, my rate law equation. So since H2, the reaction order is 1, as you double the concentration of H2, going from 0.100 to 0.200, the rate's going to double, okay, which means you're going to multiply it by 2. So again, here it is. Rate is equal to K times the concentration of NO to the power of 2. That's the reaction order for NO. And times the concentration of H2. And the reaction order for H2 is going to be 1.